What's the most important reference in chemistry? Well, it must be the periodic table, and that's what we're talking about today. So, as we remember from previous lessons in this chapter, um, every single element on the periodic table has a couple numbers associated with it. So let's take, for example, carbon has a couple numbers associated with it. Now, the very first thing is we remember that this top number is called our atomic number, and the atomic number represents the number of protons. Also the number of electrons in a neutral atom. Now, we notice that on the periodic table, we have one in this classroom on the wall, and you have one as well in your binder. And if you don't have that periodic table out right now, you should have it out right now. And you'll notice that the periodic table is arranged by increasing atomic numbers left to right. And so what's happening here, let's just kind of come down here to the periodic table and look at it. You can see that starting up here right at the top with hydrogen, there's atomic number 1 on hydrogen. It goes straight across to helium, which is atomic number 2, and then it wraps back around much like we would read a book. So it wraps back around to lithium, atomic number 3, beryllium, skips over to boron, then carbon, then nitrogen and oxygen and fluorine and neon, and so on and so forth. And it just keeps going back and forth, increasing atomic number. And so as you can see, we have about 118 total elements on the periodic table. And you might notice that there's this section below pulled out, and these have been pulled out right here. And the only reason we pull those two out, well, there's a couple of reasons we pull them out, but the biggest reason is so the periodic table can fit on a wall or can fit on a piece of paper. If we didn't pull them out, it would make the periodic table double wide, and so that's what's going on there. So really, you keep in mind that these two rows down here below have been pulled out of the periodic table, and that's why you see 57 that should fit in right here. And you have Ba, which is barium, 56, and then it just jumps right to 72. So keep that in mind on the periodic table. Okay, so increasing atomic number left to right is the way the periodic table is arranged. You'll also notice that for the most part, it is an increasing atomic mass going left to right, but there are, of course, there's a few exceptions. If you look down here, right in the middle of the periodic table with cobalt right here, cobalt has an atomic mass of 58.9. And then it drops down one to 58.6 and then increases to 63 there with copper. So there, of course, are exceptions to the atomic mass, that bottom number, but the top number, it does stay the same. So protons are increasing left to right. Let's talk about a couple very, very important distinctions in the periodic table that we need to keep in mind. The very first one there is, what is a group or a family? I call them mostly groups, but occasionally you'll come across the wording family. And these are going to be vertical columns of the periodic table, vertical column being up and down. And these are going to be elements with similar chemical and similar physical properties. So some students like to get their periodic table and actually just shade some of these things in, and you can go ahead and do that if you like. So what are we talking about with a vertical column? Well, this would be a vertical column right here that I'm coloring in. And so this we would call group, and it's titled group 1A. And you see there's some numbers and letters at the top, group 1A. But it also has a name, and we'll get to those names here in a few minutes. So that is a group or a family. And then, over here on the other side, we have another group, vertical column going up and down. Similar chemical and physical properties. So everybody in this group that I just highlighted here are what we call noble gases. And these guys do not react very readily with other elements on the periodic table, and that's why they're grouped together. Whereas the group that I kind of highlighted over here, group 1A in blue, these all react very similar, with the exception of hydrogen, and we'll talk about hydrogen as well, but most of the other ones do react very similar. Lithium right here is a metal, and lithium reacts very violently with water, causing liberation of hydrogen gas and often can explode. Sodium will do the same thing, potassium will do the same thing, rubidium will do the same thing, cesium will do the same thing. They react very similar. Okay, let's erase some of this off here real quick. And we'll talk about now a horizontal row, which we call a period. Periods or horizontal rows, they go left to right across the periodic table. So we would say, and you'll notice, we'll say hydrogen and helium are going to be in the same period, and we would call that period 1. And you notice there's a little 1 right next to it there. So that would be period 1. And then we have lithium and beryllium, and then boron, carbon, nitrogen, oxygen, and neon. Those are all going to be period 2. So it jumps across that gap there. They're all in the same period. And I would not color these guys all different colors because you're really more worried about, if you're coloring, you're worried about your vertical column, your groups. Okay, so keep that in mind. And obviously periods are just increasing atomic numbers going across, and we'll also analyze periods more in detail later on in this class. So let's talk about now one of the biggest distinctions on the periodic table between two types of elements. And if we look over here, I'm going to pick a color here. If we look over here to the right side of the periodic table, we notice that there's this kind of bold stair-step line that goes. Notice how that goes up and down. And you see it on your periodic table as well. Now this breaks apart the two largest groups on the periodic table. Everybody, well, most elements to the left of that stair-step line, we term metals. Metals share some properties, things like the ability to be drawn out in a wire, the ability to be solids at room temperature for the most part, not always. Things like that, the ability to conduct electricity and to conduct heat, for the most part. Those are all metals. So we could ask you, calcium would be designated as a metal. It would also be designated as being in group 2A, and it would be designated as being in period 4. All those things are true, but it is a metal. And we'll give it another designation here in a little bit. Now, if you're looking to the right of that stair-step line that we just talked about, that stair-step line that I highlighted in green, these are nonmetals, which often have the opposite properties of metals. They don't necessarily conduct heat very readily. They don't conduct electricity very readily. Things like that. Tough to draw them out into a wire. They're often gases. Some of them are solids at room temperature, but many of them are gases. Not necessarily all of them, though. Okay. Then, if you actually touch the stair-step line, for the most part, for example, let's say silicon. Silicon is atomic number 14 right here. It touches the stair-step line on two entire sides. And so we're going to call most elements that touch that stair-step line, there's a couple different names they go by. Semi-metals, also known as metalloids. So they use both of those pretty readily. So silicon, okay, let's highlight some of these here. So silicon, germanium, arsenic, some of these guys, semi-metals, okay, touching this there, not polonium though, really. Okay, aluminum doesn't necessarily count for that. Aluminum acts more like a metal, even though it does touch that stair-step line. Okay, so those are some of our big distinctions there: metals, non-metals, semi-metals. So oftentimes, maybe a test question might ask you, if they gave you a list of, let's say, calcium, nickel, let's say zinc and sulfur, and they asked you identify which of these four is a non-metal, you would just need to look to the right of the stair-step line, and there's only one element that is right at the stair-step line, and that would be sulfur. Sulfur is located right here, very much right at the stair-step line, where everybody else, calcium is located over here, nickel here, and zinc here. They're all located to the left. They're all metals. Okay, let's talk about some other. Okay, so a few other designations that we have on the periodic table is we do have some names for some of our groups. Remember, a group is a vertical column. So group 1A has the name of alkali metal. So we would say that anybody in group 1A is an alkali metal, with the exception of hydrogen, which kind of hangs out at the top, and we'll talk more about hydrogen later. So these are alkali metals. If you are in group 2A, so we'll say group 2A, or 1A is an alkali. Similarly sounding, but different. If you're in group 2A, you're an alkaline earth metal. Those are in 2A. So everybody in group 2A, alkaline earth metal. So beryllium, magnesium, calcium, strontium, barium. Those are our alkaline earth metals, group 2A. Okay, I'm going to kind of skip across the periodic table and then we'll come back to the center. And let's go over here to the other side. We have group 8A, and I think we talked about these guys a little bit before. Noble gases, those are group 8A. So everybody in group 8A, noble gas, characterized by not necessarily reacting readily with other elements. If you're in group 7A, you're termed a halogen. Okay. 6A, we don't necessarily ask you to know that, but they are called chalcogens. But we just sometimes call them 6As and 5As and 4As and things like that. A couple other designations that we need to know about. If you are in the middle of the periodic table, so we'll take everybody here in the middle of the periodic table. All of these guys right here. We call these guys transition metals. Okay. Okay, now these elements that sort of hang out below, down here below the stair step line, also act a lot like transition metals, and we'll find out what that means here very soon. But they're also given the name of post-transition metals. Post-transition metals, and you'll notice that some of them are also semi-metals or metalloids as well, and that's okay. And then the last thing we should talk about are these elements that have been pulled out of the periodic table down here at the bottom, and we need to know that these are intertransition metals. Intertransition metals, actinide and lanthanide series. Okay, so there are different designations of elements on the periodic table. So how is this placed into use? Well, let me show you a quick little example. Okay, so what we're looking at here is a couple different questions on identifying each category on the periodic table for each of these four elements. So we have number one, K, which is potassium. Now we're going to go up and find potassium on the periodic table. There it is right there. And it's asking us to identify it by category. So we can identify it a few different ways for potassium. Number one, first and foremost, it's going to be just a metal. Because remember, it is to the left of the stair-step line on the periodic table. The largest group is metals. Now, to be more specific, and we do want to be more specific, it's going to be an alkali metal. And remember, we said an alkali metal was any metal that was located in group 1A. So it's a metal, it's an alkali metal, it's in group 1A. And that would pretty well describe potassium. We could also throw in there that it is also in period 4, because period 4 is listed right there, everybody straight across, period 4. Okay, so there we go. Let's go ahead and erase that. And let's take a look at our next one. Our next one is going to be bromine. So if you want to pause it right now and actually work out what bromine is on the periodic table and the rest of them, you can do that and then hit play here in a minute or two when you're done and check your answers and make sure you did it. Okay, so let's go ahead and pause it right now if you'd like to. Okay, so bromine. Bromine, located right here, atomic number 35. All right, so a couple ways we can describe it. We could describe it as a nonmetal. We can describe it as a halogen because it is in group 7A. And it's also in period 4, just like potassium, although it's very much a different element than potassium. Okay, the next one we have Au. Au is located right here. That's gold. So gold, atomic number 79, would be considered a transition metal. And also, of course, just a metal. And we could also say it's in period 6. There we go. And the last one is uranium. Let's find uranium down here at the bottom, atomic number 92. And we're going to call this a metal. And to be more specific, an intertransition metal. And we'll be talking a lot about uranium and some of those intertransition metals in our next unit when we talk about nuclear chemistry. Okay, so that's our talk on today's periodic table, how we organize them by vertical groups which have the same chemical and physical property, horizontal columns which are increasing atomic numbers, and then all the different categorizations of metals and nonmetals, also alkali, alkaline earth, halogens, noble gases, transition metals. post-transition metals and intertransition metals. And so have a fantastic day.